All right, we left off the last video talking about powers of I, so we're going to finish up with these two real quick. Negative exponents, remember, mean that we're going to put something in a denominator. So I to the negative 6th power would become 1 over I to the 6th. And again, we want to try to rewrite it as powers of 2 or 4. Just keeping in mind that if it's I squared, we're working with negative 1, and I to the 4th, we're working with 1. So this would become, let's see, 1 over negative 1 times 1, right? Because I squared is negative 1, I to the 4th is 1. So overall, this would become negative 1. And then I to the negative 13th, we can think about it as 1 over I to the 13th, or 1 over I to the 12th times I. That's our closest multiple of 4 without going over, which would become 1 over I to the 4th cubed times I. We're using that exponent rule a lot, the power to a power rule, okay? Which becomes 1 over, let's see, 1 to the 3rd power is just 1, which becomes 1 over I, right? Which would be, this is a square root that we don't really want in the bottom, so we kind of want to multiply it by I over I to get that I out of the denominator. We'll get to this in just a second more so, but as we're simplifying these, we will end up with, let's see, I over I squared which becomes negative I, okay? I'm fine if you just leave it as 1 over I at this point in time. All right, so if we're multiplying these, it kind of follows like similar structure as, like, pretend like we were multiplying negative 5x times 3x, right? We have some like terms, sort of, for multiplying together. So what would you do with negative 5x times 3x? Well, you would multiply the numbers together, and then x times x will become x squared. Same thing here, right? Negative 15, because we'll take our numbers, multiply them together. I times I will give us I squared. Remember that I squared is equal to negative 1. So then negative 15 times negative 1 will give us a positive 15. All right, we'll keep on moving. We got to be really careful with these, all right? Go ahead and put a star next to this problem for me. Go ahead and put a star here because we got to be super, super careful. We have two numbers that are negative under square roots. Everything in you is probably going to want to just take the square root of negative 6 times negative 15, which will give you the square root of, let's see, what is 6 times 15? 90. But we cannot do that here. All right, so if it helps you, like, write out that work and then put a big X over it, because we cannot do that here, right? We have to write in terms of I first. Write in terms of I first. Then simplify, right? Otherwise, we're going to get kind of the wrong sign. Okay, so let's do it, right? So this will become I times the square root of 6. I'm just kind of skipping a step here because if we take square root of negative 1 times 6, then that square root of negative 1 comes out front as I, okay, times I root 15. And then now we'll take, we're multiplying I times I, which becomes I squared. And then now we can take the square root of 6 times the square root of 15, which will give us the square root of 90. This will become, I squared will become negative 1, so negative square root of 90. And we want to write this 90 in lowest terms. We want to simplify as much as we can, so we want to take 90 and see what are some perfect square factors. I know that 9 is a factor, and 10 is a factor as well. So I can rewrite this as the negative square root of 9 times 10. This square root of 9 is going to come out front as a 3. And then that 10 will stay underneath the radical. Right. Pause the video, give this one a try. All right, hopefully you followed some work process like this. I root 8 times I root 6, which turns into I squared times square root of 48, negative square root of 48, and then we end up with negative 3 roots. Let's see, actually, let's break this down just for the sake of showing people how to do this, right? 48, we take, let's see, 3 times 16. Yes, 16 is a perfect square, so we can take negative square root of 3 times 16, which becomes negative 4 root 3. I believe that's what we should end up with. Okay. With this one, we have a negative square root and then a regular square root, so we'll take this I root 5 times square root of 7, multiply our square roots together to get I root 35. Okay, dividing imaginary numbers, same idea. We got to be careful. Write in terms of I first. Write in terms of I first. Then simplify. Okay. So let's see. Take I root 80 divided by I root 5, and you'll actually notice that those i's are going to cancel out. All right, those i's are going to cancel out. And then let's try to take the square root of 80 and break it down. All right, so the square root of 80. 80 can be broken into 4 and 20. Right, and then 20 can actually be further broken down into 4 and 5. So when we write this as a simplified radical, we'd end up with 4 root 5 over the square root of 5. And if you saw that this 80 can immediately go into 16 times 5, with 16 being the perfect square, then that's great, right? I can teach this method. I'll make a separate video on this breaking down square roots method, and I'll link it in this section, okay? Cancel out your root 5s, and you end up with just positive 4. All right, go ahead and give this one a try. See what you can do. All right, hopefully you have paused the video and tried it out. Let's rewrite in terms of I first. So we'll have I root 40 over square root of 10. Which could turn into, this 40 could turn into 4 and 10, right? So we could turn this into I times the square root of 4 times the square root of 10 divided by the square root of 10. So those square roots of 10 will cancel out. We're left with I root 4. 4 is a perfect square. Square root of 4 is 2. So we end up with 2I here. So that's imaginary numbers, just an intro. Next thing in the section has to do with solving square root equations. So what imaginary numbers do is they allow us to solve equations that we would not have been able to solve before with real numbers or factoring or anything, okay? So x squared plus 64 equals 0. If this said x squared minus 64 equals 0, then we could factor it, right? We could factor it into x plus 8x minus 8 equals 0. But that's not the case here, right? We have this plus sign, so we can't just factor it. If you try to factor it, you're going to get the wrong thing, okay? You cannot factor this. So what we have to do instead is use a square root to solve. So let's subtract 64 from both sides to get x squared equals a negative 64. Then now, to undo that x squared, we're going to take the square root of both sides, and you'll see now why this is going to be valuable. Right? The square root of x squared would equal the square root of negative 64, and here, because we introduced that radical into the problem solving, we have to include a plus or minus sign. All right, so x is equal to the plus or minus square root of negative 64, and then we are going to simplify from here, right? Plus or minus square root of 64 is 8, and then we have that negative in there, so we want 8i. Okay. Pause the video, try this one. All right, if you're stumped, then let's solve it out. 4x squared equals negative 100. x squared equals negative 25. Take the square root of both sides, right? Because we are the ones who are introducing the square root into this equation. We have to include the plus or minus. So x is going to be equal to plus or minus 5i, because 25 is a perfect square, and it's negative, so we got to include that I in there. Okay. So just to try to connect some dots for you, parabolas that are like this, that have two imaginary roots, they're ones that will not touch the x-axis, right? Remember how earlier in this chapter we talked about x-intercepts being your real solutions? Well, these parabolas that don't touch the axes, they don't have real solutions, they have imaginary solutions. Okay. So that's that. Give the practice a try. Let me know what questions you have. This is a pretty new concept. We've never even considered imaginary numbers before, and it gets to be pretty abstract at this point. So do your best, and we'll get through it together.